Welcome back, guys. In part one, this is where we left off. I was showing you guys the CAD model that I came up with for this headlight project, and now it's time to start 3D printing some of these parts, wrapping things in carbon fiber, really getting down to the fun stuff. So let's get started. So the first thing to be printed here is what I called the shroud in my last video, and this piece just sits underneath all of the headlight components, and it's just a piece that you can't see the bottom of the headlight bucket and anything behind the headlights itself. This is the piece that's going to be wrapped in carbon fiber, and I already have that video up on my channel, which you can watch if you click the link down below. And this is printed out of PLA, and so this has a lower melting temperature than ABS plastic, and it's one of the reasons why I am wrapping this in carbon fiber. So it's not just for looks, but it will also protect this material from the heat given off by the headlight itself. I'm going to be using by Xenon headlight projectors, and those things kind of get pretty hot. HID lights do tend to put off and radiate a bit of heat. I do not want this thing to warp or melt in the heat, and I don't want it to also warp or melt in the sun, because of course these things will be exposed to sunlight if I park the car outside. And so wrapping it in carbon fiber will help it maintain its rigidity and protect it from warping or melting. So you can see it's coming up to the end here, and this is the final result. Now that all the 3D printed parts are complete, we can finally move on to see what we're dealing with on the vehicle itself. So on the passenger side, you can see that I've completely removed the headlight from the car, and on the driver's side, you can see that I've only removed the lens from this aftermarket headlight kit. And as we take a closer look, I just want to show you guys what's going to be replaced. And so these are the guts of the headlight, if you want to call them that. And you can really see here when I start to shake things around, like the shroud and the headlights themselves, it becomes evident how poorly designed this headlight kit was. Everything moves around and it bounces, and this is really obvious when you're driving the car. Your headlights, you can see them bouncing, you can see your cutoff pattern bouncing. It's really distracting and it's really annoying. So of course, we're going to make them solid inside. We're going to fix this with the new design, and we're going to implement everything just the way I designed it in CAD. Okay, so I gutted the driver's side headlight to have better access to everything inside. I got the base plate that you saw in the CAD design. I had that water jet cut out of aluminum. And what I didn't show you in CAD was how these lights are going to be aimed. So the base plate is going to sit on the bottom. There's a few other things I need to add in there first. We're going to go through that in a minute. But the base plate is going to control the pitch of the headlight. So how it's aimed up and down. Basically, it's vertical aim. So let's go ahead and prep this for all of the other components on there and get it mounted up. So with the base plate and the spring system installed, you can see how easy it is now to adjust the vertical aim of the headlights by simply loosening or tightening the front or back screw. And all I have to do to bring up the back screw is just simply loosen it off a bit, and you can see the angle increase. And as I tighten it, you'll see the angle decrease. And that'll make it really simple when I go to actually aim the headlights when everything's done. And that takes care of the vertical adjustment of the headlights. All right guys, so now with everything 3D printed, it's time for a quick test fit of all these parts. Make sure everything fits nice in there. and the lens will go on top without any interference. If things build too high, you're gonna have to go back and redesign everything because it's not gonna fit under the lens, and that's not something that I wanna change. So let's pop on this vanity piece. Goes right there. And now we're gonna put in the projector. You'll notice that I've already sort of pre-assembled it inside the mounting bracket. And the same thing, this bracket was water jet cut, and it's just got a simple bend in it. On the back side, you'll notice the projector. They're very similar to the Morimoto H1 by Xenon projectors. So they just mount with a mounting thread, a large nut, and you have this washer that you can use to sort of clock it and lock it in. It's like a tabbed washer. On the front side, we have a custom billet aluminum shrouds for these projectors. And I got these online off a guy that makes custom shrouds for Porsches. And I had him laser engrave Corvette performance optics on there. I don't know if you can see that, but it's a really nice touch. And yeah, so let's test fit these. And then we'll grab the LED pod. And that gives you a pretty good idea of how it's going to look inside the housing. Now, the last thing to do is fit the lens on top. Cross our fingers that it fits. And it seems to fit fine. So none of the edges are lifted, and that means there's no interference on the inside. So it's pretty good to go. And I'll give you guys a quick look down low. Move the camera down a bit. Excuse the shakiness. And that's what it'll look on the inside. All right, so before I put in all of the other components that are now ready, we have to take care of the wiring for this project. And for this, I have the Morimoto by Xenon relay controller harness, and this is from the retrofit source. And the projectors that I'm using for this project are very similar to the H1 Morimoto projectors, which are super popular for retrofits. And this harness is compatible with the projectors I'm using, as well as the H1 projectors. And what its purpose is basically to take power directly from the battery, rather than to draw power from the stock wiring harness to power the HID ballast. And the reason you want to do this is you want to have a nice, reliable, solid electrical connection. Sometimes the stock wiring harnesses aren't great for powering ballast. You may end up with HID flicker or a few other issues. And so this eliminates those issues. Like I said, you get a nice, reliable connection right to the battery. So of course, that's what we want. As well as it also grabs the signal from the high beam signal from the stock harness, and it tells the relay when to activate the high beam solenoids in our by Xenon projectors. And of course, in a by Xenon projector, like the ones I'm using, you get both low beam and high beam function in one single unit. So let's go ahead and install this, and I'll show you how I wired it. With the installation of this wiring harness, I wanted to find a location for the relay that was hidden away, and so I could make the whole installation look very stock. I didn't want wires sticking out everywhere. And the next thing I wanted to do was also I didn't want to modify the harness. So the least amount of wires that I had to cut, shorten, and lengthen would be the best. So the solution that I found was to remove all the hardware in these buckets. And underneath the bucket, you'll see that I have a nice surface here that I could potentially attach a relay to. And so I'm gonna go ahead, and this is just plastic. I'm gonna drill a small hole in this tub, and I'm gonna mount the relay harness somewhere down here, out of the way. And I already checked beforehand, but all of the wires will reach both the passenger side and driver side headlight. And the only wire that may need to be extended is the power wire that goes up to the battery. And so I'll probably just have to add a little jumper onto that. And that's it. I can install it in there, and I can start routing all the wires. So with the relay body now mounted securely, I can start laying out the harness throughout the car and make sure all the connectors are leading to the right places. So to start, this first connection here is for the signals to pick up from the stock harness. So one's for high beam, one's for low beam, and one is a ground signal. Now you'll notice if you look back here, the stock Corvette connector is a lot different than this one. This is intended for an H4 bulb. The Corvette has a unique harness here because it used to have pop-up headlights. So two of the connections there used to be for the motors. Now, instead of splicing into this harness, the old headlight kit had a connector that interfaced with this one. I'm gonna chop the ends off that. We're gonna solder on a female version of the H4 connector. And so I'm gonna make a little adapter harness. Also, of course, we need to grab power. So this is the battery cable that runs back to the battery. Battery's in that direction. It's a little hard to see, guys, because the Corvette has the front flip hood. So you can't really see back there. But we're gonna be adding a jumper cable to extend that back to the battery. Your next two connections here, one is for the ballast and one is for the projector solenoid that I mentioned earlier. I've already stripped the connections off the end because we're gonna have to feed these through a small grommet hole in the headlight buckets. And you have the exact same two connections for the driver side, which here's this wire. It's a lot longer. It's just gonna run across the front of the car. I'm gonna tuck it up under the front bumper, so you're not even gonna be able to see it. It's gonna exit out over to the driver's side, and the same thing, I've removed the connectors so I can feed it through the grommet in the other buckets that hold the driver's side headlights. And it's gonna be a nice clean install. Once I feed those wires through the grommets, I'll be able to attach the connectors back onto them, and we'll have a very stock looking wiring harness. So after a few minutes of cutting, splicing, and soldering, this is the harness that I came up with. The one end will be the H4 female, which will of course connect to the H4 male on the wiring harness. And the other end will adapt to the Corvette plug that comes on the car. And this is the one that I chopped off of the aftermarket headlights. So let's go ahead and connect these and make sure everything fits. Fits fine. All right, so they both fit. I'm gonna, of course, tuck those wires away and hide them. And the factory connector has a little slide-on piece right there, which will hold it in place. So now that I have the wiring harness sorted out in the engine bay, I was able to run the wiring harness back into the plastic headlight housing and repin all of my connectors. I also installed ballast. This is just gonna be sitting underneath that main base plate with the carbon fiber piece on top. And so that's hidden out of sight and out of view. And I need some extra room back here for some of the additional wiring. So that actually is a great spot for this. It frees up some room in the back. And so let's go ahead and put the base plate back in and start test fitting some of the parts. Make sure everything still fits in there and make sure we have enough room for this wiring at the back. And before we can test fit these parts into the headlight buckets, there are a few remaining things that we have to do. And we have to drill and tap a few holes just to get everything to bolt up together into the subassembly. And you'll notice that the 3D printed part that I had earlier has now since been wrapped in carbon fiber, and the results are great. I'm really happy with how it turned out. If you guys are interested in learning how to do this for yourself, I've also posted a video on that. You'll find the link in the top of this video as well as in the description below. And I'll take you guys through how to wrap your 3D printed parts, or any other part for that matter, in carbon fiber. And behind that you have the 3D printed LED pods. So of course these are running the daytime running lights. And behind that I've wired up the custom PCB board that I also designed. And this is to sequence these daytime running lights every time the car starts up. At the end of this video I'll show you guys how that works and how that turns out. If you want to know how to make your own PCB boards, specifically this design, I have the circuit design and the whole process of making the board in another video as well. You'll find that link up in the top corner of this video, as well as in the description. All right guys, thanks again for watching. Part 2 is done. I hate to leave you guys hanging, but in part 3, we're gonna finish up the rest of this build. And of course, I'm gonna show you the results. So be sure to subscribe and don't miss part 3.